Hi, my name is Eduardo Zabinal, and the physics phenomenon that I decided to choose is called Newton's cradle. So what is exactly Newton's cradle? Well, first of all, the Newton's cradle is named after the well-known Sir Isaac Newton. Although he wasn't necessarily the inventor behind this project, his concepts of science are what drive this device to work. So back to the Newton's cradle itself. What is the Newton's cradle? Well, the Newton's cradle is a device that demonstrates conservation of momentum and energy via a series of swinging spheres. When one sphere on the end is lifted and released, it strikes and transmits a force through the stationary spheres, which pushes the end sphere upwards. There are three main physics concepts and principles for this Newton's cradle. The first is the conservation of energy. The second is conservation of momentum. And the third one is friction. The law of conservation of energy states that energy can't be created or destroyed. However, it can change forms, with the conversion of potential energy into kinetic energy and vice versa. For example, when the first ball is lifted up and out, its kinetic energy remains zero, but potential energy becomes greater. After the ball is released, its potential energy is converted into kinetic energy. When ball 1 hits ball 2, it stops immediately and its kinetic and potential energy go back to zero. But the energy must go somewhere else, into ball 2. The energy is transferred as potential energy. But when ball 2 returns to its original shape, it converts the potential energy into kinetic energy again, which transfers to ball 3. This chain continues until ball 5. However, ball 5 has nothing to transfer its energy to, so ball 5 will swing out with the same amount of kinetic energy and speed as ball 1 did when it first hit. Momentum is a vector quantity, which means that the direction of momentum matters. Like energy, momentum is conserved. When ball 1 hits ball 2, it's traveling in one direction, which carries the momentum throughout all the balls. The small time between ball 1's impact on the end ball swinging out is where momentum is conserved. If an ideal Newton's cradle worked perfectly, it would mean that the balls would continue to swing forever. This would consist of only energy, momentum, and gravity acting on the balls, perfectly elastic collisions, and perfect construction of the cradle. However, it is impossible to have an ideal Newton's cradle because one force will always conspire to slow things to a stop: friction. Friction robs the system of energy, slowly bringing the balls to a standstill. So, what is the mathematical equation for the Newton's cradle? Well, in accordance with the Newton's cradle, the law of conservation of energy states that the kinetic energy of the moving ball on one side is equal to the kinetic energy of the ball leaving the other side. So, another way we could write this is saying that EI, which we could say is initial energy, equals EF, which is the final energy. And using kinetic energy, we can say that 1/2 mv squared equals 1/2 mv squared. Here are more elaborate equations that you may use to your convenience. Pause and use as you may.